Hey guys, I'm Professor Science and today you're going to learn about the extraction of iron. So before you learn about the extraction of iron, you need to be aware of some common terms which are used in the extraction of iron and you need some introduction. So let me give you that. You may or may not know that iron is the fourth abundant element in the world. Its atomic number is 26. There are two types of iron ores from which iron can be extracted. They are hematite and magnetite. So in our extraction, in the extraction of iron, hematite ore is used. Uh, there may be some common doubts. Why not magnetite? Why only hematite? Magnetite has some other uses like making magnets and many other various types of uses. But hematite does not have any use. Therefore, instead of letting it go to waste, we use hematite as the ore from which iron is to be extracted. And you need to be aware of some common terms. They are gong. Gong is the unwanted impurities present in the ore. The hematite ore is not completely pure. They contain some impurities called the gong. And next, concentration. This process is simple. Concentration is the process of removing the impurities. Concentration is the process of removing the impurities. And the next is roasting. Uh, in the hematite ore, the melting point of hematite ore is more than the melting point of the gong. So therefore, the hematite ore is heated where gong melts but hematite does not melt. So that process is called roasting. Next, calcination. In the process of calcination, water molecules are absorbed. Calcination is the process where water molecules are removed. And the last term is the flux. The flux is a substance which is used to remove the impurities which are not removed by the concentration. So, in the process of concentration, uh, the the impurities called gong are not completely gone. So, therefore, by adding flux, the last part of the impurities are removed. Now, let us jump into the process of extraction of iron. Hematite ore is used as the ore from which iron is to be extracted. The method of concentration of hematite ore is called hydraulic washing. In the process of hydraulic washing, this is nothing but the concentration of the ore where the gong particles present in the hematite are removed. In hydraulic washing, the hematite ore, assume this is a hematite ore, it is crushed and fed into a tank-like structure with an opening. Here, the crushed hematite ore is filled here, and this hematite ore is washed with a stream of water. The washes out the lighter gong particles. There are gong particles in between the hematite ore, and these gong particles are lighter than the ore particles, and the water current flushes out the gong particles, leaving behind the heavier ore particles. Now, due to the washing of the ore with water, the water content in the hematite is increased. So, to remove the water content, a process called calcination is done. Calcination is done to remove the water content present in the hematite ore. Then, now the washed ore present is a mixture of hematite. It's a mixture of hematite and silica. Silica is an impurity. It's nothing but sand. Silica is an impurity which does not disappear when it is hydraulic washed. When the water current is let through inside the hematite ore, the lighter gong particles flush out, but silica is having a property of a strong affinity and does not leave the hematite ore. This impurity is still present. So we cannot extract the iron successfully from hematite ore if silica is present. Therefore, a mixture of limestone, which is nothing but calcium carbonate, with a mixture of coke in proper proportion are mixed with the hematite ore to remove any impurities. In this case, silica is removed by the mixture of limestone and coke. Now, what is the role of the limestone? Limestone removes the silica from hematite ore, making it completely pure. And as I explained before, the substance added to the ore to remove the gong particles which are not removed in the concentration of the flux. Limestone is nothing but flux, and the coke acts as a reducing agent. This pure hematite ore with a mixture of limestone and coke is called as charge, and this charge is fed into a furnace called blast furnace. Inside the blast furnace, limestone decomposes into quicklime and carbon dioxide. The limestone, which is present in the charge along with the hematite ore, decomposes into quicklime and carbon dioxide. For your information, quicklime cannot be found in the free state. It is always found in the combined state. And the next process, the quicklime. The quicklime combines with silica. The silica is the extra impurity which does not go in the concentration, combines with silica, sand, which is nothing but sand, to form calcium silicate. Now this calcium silicate is nothing but slag. Slag is nothing but calcium silicate. Now slag is a waste material in this, but it does not get completely wasted, as this material is used the in the preparation of glass. Calcium silicate is used in the preparation of glass, so it can be recycled. And the next stage, coke. Coke oxidizes into carbon monoxide. This is a bit confusing, but I'll make it easier for you. The charge is composed of quicklime, and this is the limestone and quicklime and silica, coke, carbon monoxide and iron oxide. These are the components which are present in the charge. Now, in this first step, limestone decomposes into quicklime and carbon dioxide. So, the role of limestone is complete. Limestone is gone. And next, quicklime combines with silica to form calcium silicate. So, the role of quicklime is done and silica is done. Then, coke oxidizes into carbon monoxide. It oxidizes into carbon monoxide. Now the role of coke is done. And carbon monoxide reduces iron carbon monoxide reduces iron oxide into pure pure iron. CO plus Fe2O3 Fe plus CO2. Carbon dioxide gas is liberated. Pure iron is obtained. These are the four stages which are taking place inside the blast furnace. This is a diagram of a blast furnace. This is the part where the charge is fed and your hot gas is blown. Hot gas is blown from here and the temperature reduces as it goes upward. Here limestone decomposes into quicklime and carbon dioxide. Quicklime combines with silica to form calcium silicate or molten slag. And coke and this is the slag. Carbon monoxide reduces iron oxide into pure iron. Pure iron is here. This is an opening for slag, but it is not thrown out because here carbon dioxide and various other gases are present. And if the slag is removed, the pure iron, this is the pure iron. The pure iron which is here again oxidizes into iron oxide. So to prevent further oxidation, slag is kept floating above the pure iron and the pure iron flows out of here. The molten iron, its temperature is very high. The molten iron flows out from the opening of the blast furnace. And this is the pure iron. The pure iron obtained is called pig iron. So this is the extraction of iron. Thank you for watching my video. Make sure you subscribe and like. Thank you.